Hello, welcome to another video on Financial Math for Actuarial Exam 2. You can see I'm working in a spreadsheet for this video. That's because this exercise 6.1.3 is pretty tedious to do without a spreadsheet. You would not want to see me doing it without a spreadsheet. So that'll help us solve the problem efficiently. It will also provide us with an opportunity to review the use of spreadsheet and good spreadsheet usage. So here's the situation. We've got a 10% bond with a face amount of 100 that matures in 3 years. Now, it's not said that this is a semi-annual coupon bond, but that would be the assumption you would make if it doesn't say. It also doesn't say that the bond is redeemed at par at the face amount, but that is the assumption you would make if it doesn't say. Okay? So the 10% is going to get converted to a semi-annual coupon rate of 5% by dividing it by 2. And our main goal is to find both the value, or the price, and the yield of the bond under 3 different term structures. Now, we talked about term structures in the last video. We've got 3 different term structures that you can see here in terms of what are called nominal annual spot rates. SPT RT stands for spot rate here. R sub T is the spot rate at these various times that are in half years: 0.51, 1.52, 2.53. So again, 3 different term structures. You can graph these term structures. You can graph these spot rates as functions of the term structures. What the spot rates really are, and here are the graphs, is that they are yields of zero coupon bonds for these different terms. Here's the term of the zero coupon bond along the horizontal axis, and the yield as a nominal annual yield in this case of a zero coupon bond for these different terms. The first term structure right here is the most common case in real life. That's an increasing function of the term. That's the blue graph that's going up. As the term increases, the yield goes up. That's what usually happens, and that should make good sense. You would typically think if your money's locked away for a longer period of time, you'd want a better yield, a better return, to compensate for keeping your money locked away for so long. However, it does sometimes happen, as it did in the last video, that the yield curve is inverted and it's a decreasing function. That's the red graph here. That's an inverted yield curve. It's not typically something that happens in real life. Okay, though it might happen somewhat approximately, you might say. And then finally, the last term structure is a constant or level term structure. The yield curve is horizontal. That doesn't typically happen exactly in real life, though if it happens approximately, you could still say it's approximately level or flat. All right, also, besides finding the value and the yield in this situation, we are also finding these things when we change the coupon rate from 10% to either 8% or 12%. And the spreadsheet is going to allow us to do all these things very efficiently, okay? So you're also going to want to think about and maybe write down what I do in the spreadsheet to help you learn how to use spreadsheets in good, efficient ways. In particular, to use formulas in spreadsheets and built-in functions. The equal sign that I'm typing here in B6 is the indicator to, in this case, Excel, though it works in other spreadsheets like Google Sheets, to do math. And what I'd like to do is I'd like to take 100 times 0.05 here, the numbers that are in cell B4 and B5. But instead of typing in that product, which of course is 5, I'm going to type in the cell references, or in fact I can also just click on the cell references. You see an equals B4 times B5. That's going to take what's in B4 and multiply it times what's in B5. And it's got the benefit of being updatable, you might say. If I change what's in B4 to 4%, it changes the coupon amount to 4. 100 times 4%. If I change the face value to 200 instead of 100, I could do 200 times 4% is 8. Okay, so that's a really good thing. You want to use formulas in spreadsheets so everything gets updated correctly. We're going to continue doing that with formulas down here to help us do the problem. I'm going to fill in the period column, the number of half years. What's the overall strategy here? I'm going to take these nominal annual spot rates for these 3 different term structures. 3 different term structures that you see there, and I'm going to convert those, because our periods are half years, I'm going to convert them to effective periodic spot rates, effective semi-annual spot rates, by dividing them by 2. Those are the numbers that are going to go over here. I'll put the payments to you, the bondholder, in this column. This would be then, for the first case of 5% semi-annual coupons, 5, 5, 5, 5, 5, and then 105 at the end. And then I will convert those, based on the 3 different term structures, to present values of those payments. I will discount back to time 0. I will add up those prices. And then I will, so those will give me the answers for the prices or values of the bonds. Then I will compute the effective semi-annual yield and the nominal annual yield using a built-in function called IRR. But to do that, I'm going to need to first convert the price to a negative because I'm thinking of it as outgoing money. The parentheses means negative. Those numbers will go here. Then I'll put the payments here for the three different term structures. Use the IRR to compute the semi-annual yield as an effective semi-annual yield. This, by the way, the spreadsheet doesn't know you're thinking of things semi-annually here, so you have to know that. And then to convert that to a nominal annual yield, I'll have to multiply those by 2. So that's the overall strategy. Now let's fill in the details. By the way, I did fill in this column here with formulas. In this spot right here, cell A11, I typed this formula up here. It's kind of small. It says equals A10 plus 0.5. I took what was an A10 and added 0.5 to it. And the great thing about that is that formula can be easily copied and pasted downward. I can either do that with a copy and paste, or I can click and drag. Highlight the cell, go to the lower right corner, click, drag, and those numbers come up correctly based on updated formulas. The spreadsheet, as I copy and paste downward, automatically kept the A fixed, but changed the row, kept the column fixed, but changed the row from being a 10 to an 11 to a 12 to a 13 to a 14 to a 15. You can see up here it says equals A11 plus 0.5, even though I never typed that. Down here it says equals A15 plus 0.5, even though I never typed that. That's good. That's a good thing. I could do a similar kind of thing in this cell. I could take equals B10 plus 1, this is the number of half years, and I could copy and paste this formula down. The B would stay fixed, the 10 would get updated to an 11, then a 12, then a 13. It just adds 1 to the previous number. That's one way I could do it. I also, just for fun here, I could also multiply the time by 2, like this. And then if I copy and paste that formula downward, the A will stay fixed, but the 11 will get updated to a 12, then a 13, then a 14, and give me the correct number of periods. So 3 years, but 6 half years, 6 periods here. That's going to be a handy thing to have as I continue to the right now. All right, and let's do that now. Let's continue to the right. Now I want to fill in these effective spot rates in each of the 3 term structures. Term structure 1, 2, and 3. Take all of these numbers and divide them by 2. I can do that with the formula and copying and pasting as before. I can do, for example, here in cell F11, I can do equals C11 divided by 2. If I copy and paste that downward, it'll keep the C fixed and change the 11 to a 12, then a 13, etc. And will then therefore take all those numbers in column C and divide them by 2. For example, 0.0425 is half of 0.085. I can also now copy and paste this over to the right. Now if I copy and paste downward, the column stays fixed, the C stays fixed, and the numbers, the rows, changed. However, if I copy and paste to the right, the column is going to change. The C will change to a D, then an E. And that's what I want to have happen, because I want to take these numbers in columns D and E and divide them by 2. But the 11, the 12, the 13, the 14, 15, 16, those all stay the same. There we go. And for example, you can see 0.065 is half of 0.13. You can see that all these numbers 0.06, which are all half of 0.12. Again, this is doing the same thing. Imagine if your table was much, much, much bigger, right? Instead of 3 years, 30 years or something like that. Definitely this formula approach with the copy and pasting would save you a ton of time. Very efficient. All right. Now let's go on to the payments. Okay, this gets a little trickier. I want the first 5 payments to all be 5s. So I could certainly just type 5s, and that's not too bad. And then the last payment is 5 plus 100, 105. But again, I'd like to have the flexibility to make changes here and have these payments, the coupon amounts, for example, change correctly. So I do want to use a formula instead of that, and that will again also be more efficient if my spreadsheet was much bigger, the table is much bigger. However, if I just type equals B6 here, which is where that coupon amount is, watch what happens. It does not copy and paste correctly to a bunch of 5s. I got some zeros in the word period. What happened there? It copied and pasted and kept the column B constant, but changed the row from 6 to 7 to 8 to 9. But I don't want to change the row. I want to keep B6, that row, constant. So instead what I can do is the following. And this is definitely something worth knowing here. I can use the $sign not as a money amount, but as a fixed cell reference operator, you might call it. I can type this equals $6 with the dollar thought of as being in front of the 6. And what that does is as I copy and paste downward, it's not only going to keep the B fixed automatically, but it's going to keep the 6 fixed as well. Sometimes people put a dollar sign in front of the column as well, and that certainly doesn't hurt in this case, but we are going to see that just using one dollar sign is going to be handy for columns J, K, and L. Okay, so it's a good thing to know. So this again, as I copy and paste downward, even without a dollar sign in front of the B stays constant. By putting the dollar sign in front of the 6, it keeps the 6 constant. We're always pulling from cell B6 here. So the dollar sign is not a money, it's a fixed cell reference operator, you could call it. It's keeping the 6, the row, constant in this case. As far as this one is 105, and I will want to use formula, and I don't have to use dollar signs here because I'm not going to copy and paste it. Actually, I'm thinking I do want to copy and paste down here. So actually, I think I'm going to change my approach. I think I'm going to use a dollar sign in front of the B as well, because I'm going to take these payments and copy and paste them down here when I compute the IRR as well. So I think I'm going to use 2 dollar signs. And if I copy and paste down there, I'm changing the columns. So I want a dollar sign in front of the B as well, and I think I'll use dollar signs here too. I wasn't initially going to think about copying and pasting it, but I will be. So I will use dollar signs, and both in front of the B and in front of the number. Again, because I'm going to be going down here into new columns as well as new rows before I compute the IRR. Okay, so that will be a good thing to do. All right, but here in these columns, it will be good to make use of single dollar signs, either in front of the column or in front of the row, but we got to think about it carefully here. I'd like to calculate present values of these payments that are in column I and keep the column the same as I go to the right. So I definitely want a dollar sign in front of the column I. Do I want a dollar sign in front of the row, 11? No, because I copy and paste downward. I mean, these are all 5, so that's not hurting anything, but this last one's 105. So I want this last one to change. So I want this to change from an 11 to a 12 to a 13, etc. So this last one becomes an I-16. Okay? I'm continuing my formula. Times, in parentheses, 1 plus what? 1 plus the effective periodic semi-annual spot rate to the negative power where the negative is in front of the number of periods. Now, I want these spot rates to change both as I go down and as I go to the right. So I do not want a dollar sign at all with the F11. Okay, because I want both. I want the 11 to change as I go down. I want the F to change as I go to the right, so that I can use what's in columns G and H as well for columns K and L. What power? To the negative of the number of periods. The periods are in column B. I want that to stay fixed, but I want the 11 to change to a 12, then a 13, etc. So I should use a $B 11. Okay, so that's discounting this first payment to time 0 by multiplying by 1 plus the spot rate to the negative of the number of periods. And that's going to be something that copies and pastes correctly, both downward and to the right. You might want to double check one of these. I think that's good, maybe with your calculator. I could also just do it with the spreadsheet here. This 3.96047, for example, would be 5 times 1.06 to the negative, it would be negative 4th power. Yeah, let's just double check that up here. Equals 5 times 1.06 to the negative 4th power should be the 3.96047, and it is. We have a match, okay? You could double check a few more of those with your calculator. That's a good thing to do. All right. Now on to the price, or the value of the bond at time 0. I need to add up these present values. You can do that with a built-in function, sum, for sum. You can highlight the column that you want to add up, or you could type what you see here, J11 colon J16 represents all these cells together. That will add them all up to give you the price. I can copy and paste that equals sum formula to the right and get these prices that are the sums of these columns. And notice the formula changed, the J changed to a K there, and the J changed to an L here for that one. Okay, that's good. So this would be the answer for the prices in the case of the 10% coupons that are 5% convertible semi-annually, or the 10% convertible semi-annually, which are 5% coupons for the semi-annual coupon payments. For these different, again, these different nominal annual spot rates, these different term structures, and corresponding effective periodic spot rates for the same term structures. We get these different prices. Okay, and it should make some sense. You think about the first regime, it's relatively low spot rates, relatively low yield, you might say that's corresponding to a relatively high price. This one here is the low price corresponding to relatively high yield rates effectively. You can think of the overall yield rate as somehow some sort of average of these spot rates. And this is the intermediate one. So those are the answers when we have a 5% here. Maybe you want to write those down. Now I'm going to go ahead and change it to a 4%, 8% divided by 2, 0.04, and everything gets updated, including these payments. These coupon payments are now 4, and the last payment's 104 instead of 105. Still have the same relative size. This one's still the biggest, this one's still the smallest, this one's still in the middle. Those prices went down, though. That's because your coupon payments went down. You're not getting as much money for your money. Your price is going down. Your yield is going up when your price goes down. Flip side, if I increase the coupon payment to a 6% semi-annual for 6 coupons here, I get higher prices, still relatively speaking. This one's the largest, this one's the smallest, this one's in the middle. And that would be relatively small yields. You can write those numbers down. All right, now we're going to go on to the final thing, computing ultimately the nominal annual yield to get the answers that match the back of the book and the solution key. So let's go back to 5%. And okay, so how do we compute this? Let's take these prices and make them negative. The parentheses again mean negative. So I could type equals negative J18 here. That's just necessary for the IRR function, kind of like on how calculators you need to include negative signs. This is outgoing money. You know, you're the investor, you're buying these bonds. This is outgoing money from you to the government entity or corporation. Treat it as negative. Now take the payments back to you as positives. And here's where using the double dollar signs will be good. I can just copy and paste this all down here. And it's all correct because I used the double dollar signs. And now I can use the IRR function, internal rate of return. You know this is an effective semi-annual yield because these are semi-annual payments. Even though the spreadsheet doesn't know that, that's okay though. Highlight those or just type J19 colon J25. Get more decimal places. Say that many. Copy and paste this over. There we go. Those are the answers in the case of the 10% overall coupon rate, which converts to a 5% semi-annual coupon rate. Multiply those by 2 to get the nominal annual yield, like that. And we could write that as a percent and increase the decimal places if we like, and copy and paste it over. Okay? Notice a couple things here before I end the video. This 12%, well, I guess I haven't done the 4% and 6% yet. This 12% matches the 12% spot rates for the level regime here. That should make sense. The nominal annual yield is lower when these nominal annual spot rates are lower, and higher when the nominal annual spot rates are higher, this column here. Let's see the answers when we have the 4% and 6%. You can write them down. These are the nominal annual yields when we have the 4% down here. And then finally the 6%. These are the answers down here. And again, this stayed 12% all the time. These changed. Finally, let me point out something interesting. When you increase the coupon rate, well, let's start with it low. And so the coupon amounts are low. Then the price is low, but the yield's relatively high. You would expect then if you increase the coupon rate to get higher coupons and a higher price, you'd get a lower yield. And that does happen in the situation where it's the ordinary situation where the yield curve here in blue is increasing, but it amazingly doesn't happen when it's the inverted yield curve, the red one here. Let's see that happen here. So take note of these numbers, 8.452% and 12.811%. I'm now going to increase the 0.04 to a 0.06. We should see then again this one going, let's see, again, increasing these numbers, increasing these. This one decreases, this one increasing, amazingly enough. Write those numbers down. Let me do it just so I don't forget. 8.4, I guess I can just type them. 8.452 and 12.811. Watch what happens now. I'm going to increase R from 4% to 6%. And what happens? This one goes down just like you would expect, but this one went up. That should seem pretty weird. You might wonder, okay, why is this happening? Perhaps it's because of the decreasing term structure here, the decreasing yield curve, the inverted yield curve. Maybe that's the reason. Maybe you should spend time seeing if you can figure out why that happens. Okay, that would be a good theoretical exercise for you. Thanks for watching.